Hello, my name is Muhammad Amir Shahir and my partner Aaron Adong. We will present Measurement Energy Chapter 6 for our group, which is Group 7. Okay, so for our content, it will be objective, introduction, electrolytic meter, motometer, clock meter, measurement of volt ampere hour, trivector meter, testing of meter, method of testing energy meter, phantom or fictitious load, and testing of AC meter. Okay, we have six objective, which is to understand how we measure electrical energy and why it's important. Second, to know the different types of energy meters like electrolytic meters, motometers, and clock meters, and how each one is used. So third one is to learn how to measure volt ampere hours and adjust meters for accurate readings. Fourth is to understand how trivector meter work and how they measure both kilowatt hour and kilovolt ampere hour. So to learn why and how to test and calibrate energy meters to ensure they are accurate, and lastly, to understand how phantom loads are used to test large meters without wasting energy. For our introduction, so in this chapter, measurement of energy can determine by using different type of method and tools. So these instruments are really important in electrical field, which is to evaluate how much energy was used over time. So there are three types of measurement meters that we usually use. First is electrolytic meter, second is motometer, and third one is clock meter. Okay, start off from electrolytic meter. So the electrolytic energy meter is designed for DC circuits and measures energy in ampere hour. Using these meters on other voltage readings will result in inaccurate readings. So it is important to note that these energy meters can be used on AC circuits, but these devices are suitable for use on AC circuits by incorporating a compact rectifier unit. They operate in accordance with Faraday's law of electrolysis. They are straightforward, inexpensive, and precise when dealing with small loads. They are immune to stray magnetic fields and friction errors. So these are the principle of measuring using electrolytic meter using alternating bipolar method. You can refer on the bottom right image. So to determine its electrolytic conductivity, a two-pole electrode is submerged in the solution. The two poles are connected to an AC power source. The electric current going between these poles is used to quantify both the solution's resistance and its electrolytic conductivity. Since the electrolytic conductivity changes with temperature, a temperature adjustment device is used to adapt the measured electrolytic conductivity to that at 25 degrees Celsius. So to the next slide. So coming to clock meter can be used in both AC and DC systems, making them a versatile tool for various electrical setups. Unlike other meters, clock meters are not affected by external stray magnetic fields. So this ensures that they provide reliable and consistent readings no matter the environment. Clock meters are exceptionally accurate when measuring small electrical loads. This makes them ideal for applications where precision is crucial. Due to their intricate construction and high cost, clock meters are not commonly used as household service meters. Instead, they are reserved for specialized applications where their advanced features justify the investment. So coming to motor meter slide, energy meters with motor mechanism contain various type of electric motor, such as mercury commutator and induction motors. The mercury motor is exclusive to DC circuits, while the induction motor is only for AC circuits, and the commutator motor is suitable for both AC and DC circuits. Most commonly used instruments in this type are mercury, commutator, and induction motometers. So there is some example of motometer, which is ampere hour mercury motor energy meter principle, where this device work. So referring on the diagram on the right side, the measuring currents enters the disc via the mercury and runs readily to the center of the disc, where it exits to the external circuits via the spindle and bearings. The stream only flows on the right side of the disc. The magnetic field of the permanent magnet M2 will apply force on the right side of the disc, which transport current. So the direction of the force may be determined using Fleming's left-hand rule. The force produces the driving torque. It cuts the field of the left-hand magnet M1, causing eddy current to flow through it. So next slide is measurement of volt ampere hour. So the relationship between watts, which is vars, volt ampere reactive, and VA is given by. Next is measurement involves integrating volt amperes over time. Okay, four methods of measuring volt ampere hours. First is the induction watt hour meter method. Adjustment of flux. The meter's flux is adjusted to lag behind the applied voltage by 90-degree plus flux, where the flux is the average power factor angle. Power factor consideration. When the power factor of the load circuit is exactly 1, the meter reads volt ampere hours accurately. If the power factor is not 1, the meter speed is adjusted to match VA cos, where angle is the actual power angle. So if the difference between angle and flux is small, the error in voltage ampere hour reading is minimal. Compensation for watt hour meter involves quadrature loops on the shunt magnet. For vector addition method, two separate meters. So uses two watt hour meter elements, one measure watts and the other measure vars. For mechanical coupling, these elements are mechanically coupled to sum their speeds using vector addition. For the calculation, the combined speed gives the true reading of volt amperes per hour following the formula. As I just mentioned just now, this method makes it so that the volt amperes hour reading is accurate, especially when the power factor angle difference is small. Lastly, for my part, is trivector meter. A trivector meter is an advanced metering device designed to measure electrical energy in terms of kilowatt ampere hours and the maximum demands in kilovolt amperes. It integrates two essential meters. First is kilowatt hour meter, second one is reactive kilovolt ampere hour meter. So these meters are housed in a common casing with a special submeter placed between them. The submeter is driven by a complex gearing mechanism that ensures accurate kilovolt ampere hour registration across all power factors. Okay, that's all from me. Coming next to my partner, Aaron Adong.
Next, we will talking about the testing of meter. So for initial calibration and adjustment, the test methods specified by the electrical supplies meter X1936 must be followed. This X also outline the types and permissible limits of errors and the necessary testing apparatus. The apparatus required for meter testing is DC potentiometer and shift chronometer or pendulum type clock. The substantial apparatus is ammeter, voltmeter, indicating wattmeter, rotating meter, electrolytic ampere hour meter, and stopwatch. So there is certain tests to be carried out. So all meters must undergo the following tests. So the first one is low load test. For meter with a rating less than 10A, it tested at 10% of mark current. If it higher than 10A, it tested at 5% of mark current. The next one is intermediate load test. It connected at one intermediate load level, and then the third one is full load test. So if it at the highest percentage of mark current as specified in the limits of errors of the class. The fourth one is power factor test, or we can call it or it is for AC meters. At mark voltage and mark current with a power factor of 0.5 link. So next is methods of testing of energy meters. So for method A, we can call it long period die test. The connection is the current coils of both meters are connected in series with each other and the load circuit. The voltage circuit of meter are connected in parallel across the supply circuit. For testing process, we can start both meters simultaneously After a suitable time, stop both meter, and then ensure the test duration is long enough for the meter pointer to complete at least 10 revolution on its lowest reading dial. For calculating the percentage error, we can use the formula R minus R over R times 100, where the 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 apostrophe R is the reading of the test meter and the R is the reading of the substandard meter. So for the accuracy, release slowly on dial readings, eliminating errors from starting or stopping meter or stopwatch. For the consistency, no need to maintain a constant load throughout the test. So there is some disadvantage of this method. It requires a long duration for a single accurate test, making the complete set of tests lengthy. And if the meter needs adjustment during testing, this method is not. So for method B, we can call it short period test using a rotating substandard. It is to test a multimeter using a precision substandard rotating meter over a short period. The standard meters larger dials can read up to 1/100th of a revolution. Both meter can be started and stopped simultaneously. The three lowest reading pointers can be reset to 0. For the procedure load adjustment, first step is adjust the load to the required value. Allow the test meter to complete a certain number of revolution. And the third one is record the number of revolution made by the standard meter during this time. So if we want to calculate the percentage error, we can use the formula energy supply equal to energy indicated by the standard Ns over 1, Ns power to the power of 1 over Ks time with Kw hash. So energy indicated by, and then we calculate the energy indicated by meter under test, which equal to Nx over Ks time with Kw2. And then for the percentage error, we can use this formula to find it. So for method C, we call it short period test using a standard wattmeter. This method is particularly used for testing direct current multimeters, DC. So for the setup, use precision grade indicating instrument as the standard of reference. Connect this instrument in the circuit with the meter under test. So the procedure is measure the time taken by the rotor disc of the meter under test to complete 3 revolutions, or any number of revolutions that makes the test period no less than 100 seconds. Then maintain the constant current and voltage during the test using an automatic stabilizer to keep the load constant. To calculate the percentage error, you can use the formula Nx over Kx minus Kw times T over 3600 over Kw times T over 3600, and then we time with 100. And then there is and then we simplify this formula, and we can get Nx times 3600 over Kx time Kx over Kw times T minus 1 and time with 100. Next, we were talking about phantom or fictitious load. The problem with ordinary loading, uh, it is high capacity meters. Testing this with ordinary loading leads to significant power wastage. So the power wastage equal to traditional methods consume a lot of power during testing. So by using phantom fictitious loading, we can minimize power wastage during testing. So the method for PC pressure circuit energized with the required normal voltage for the current circuit connected to a low voltage supply. So phantom works. So this is how phantom works. The power consumption, only a small amount of power is used. The pressure coil is operate as normal voltage, and the load currents operate at low voltage. Now, this is testing in service high capacity meters. The pressure circuit is supplied from the line as usual. The current circuit is disconnected from the consumer load, supplied from a low voltage source. The benefits of phantom loading is it can reduce power consumption during testing, and it ensures accurate testing without disrupting consumer supply. So this is the example of phantom loading. Yes. Next, we were talking about testing of AC meters. So first one is DC meters. It require only variation in voltage and current. For AC meters, it require variation in voltage, current, and their relative phase power factor. So for the phase adjustment methods, the first one is phase shifting transformers. It produces a rotating field with the 2 or 3 phase current. For single phase supply, a phase shifting device is used. Rotor phase can be adjusted by rotating it through a desired angle. The second one is coupled alternators. Two similar alternators driven by a motor, and then stator of one alternator can rotate to change the phase angle. And one alternator supplies the pressure coil circuit, the other supplies the current coil circuit. Next, the phase shifting transformer use. It requires 2 or 3 phase current for rotating field. Single phase supply needs a phase shifting device. For the operation, rotate the rotor to adjust the induced current phase angle. The coupled alternator use one alternator for pressure coil circuits, one alternator for current coil circuit. It operates. This is how it operates. First, adjust the phase angle by rotating the stator of the current supply alternator. Use a worm wheel and graduated scale to measure the phase angle accurately. Error determination. Set desired magnitude and power factor for the test. So for the error measurement, method 1, we can use time revolution and measure load with a wattmeter. Method 2, compare revolution rates with a standard wattmeter. Next is testing of AC meters. And this is the first diagram is the connection diagram for testing of single phase meter. The second diagram is connection diagram for testing of 3-phase, 3-wire energy meters. For the conclusion, the energy measurement use method that integrate power and time to calculate usage. The main type are electrolytic meters, motor meters, and clock meters. Electrolytic meters measure DC energy via meter disposition. Motor meters work for both DC and DC using rotary revolution to measure energy. Volt ampere hours VAH are measured with compensated induction watt-hour meters or by combining watt-hour and var-hour meters. Drivator meters accurately measure energy consumption and demand. Meter also must be tested for accuracy before installation. Following regulatory standard, testing method can includes long period diode test, short period rotating subtender test, and standard ohmmeter test. Phantom loading technique prevent power waste as in high capacity meters. AC meters testing also involve phase adjustment. Accurate energy measurement and testing are essential for reliable billing and effective energy management. Thank you for watching, and thank you for spend your time to watch my video.